We looked at hydrolysis, which is dumping basically a salt into solution. And we got sort of three ways. If they both were either spectators or forming strong acids, we got a neutral salt, no hydrolysis occurred. If we got one where the cation hydrolyzed, so the ammonium here donates a proton, we got an acidic solution. We called it cationic hydrolysis. So cationic gives you an acidic solution. And if we had anionic, where's an anionic? Sodium phosphate one. The phosphate group, because we don't care about sodium, the phosphate group picks up a proton and we formed a basic solution. So anionic gave us basic, cationic gave us acidic solutions. There were neutral, where if they both formed a strong acid or base, nothing happened because strong acids and bases dissociate 100%. And then there was the kind where you got both happening, double hydrolysis. So you had, in this case, the ammonium sulfite. The ammonium group can donate a proton. You got cationic. The sulfate can accept a proton, and you form this weak acid, HSO3 minus. All right, so it doesn't ionize or push back 100% the other way. So we called it double hydrolysis. Today we're going to look at, is that going to be pH greater than 7 or pH less than 7? In other words, of these two things that happen, which one wins? Okay. So ammonium nitrate. Okay, so we got ammonium. And we got NO2. Right? The salts always split up. If ammonium reacts with water, it's going to donate a proton. And we get that happening. And the NO2 can accept a proton. And we get this happening. So we got cationic and anionic. First thing you ask yourself, is HNO2 a strong acid? Right? Truss acid. Is it a strong acid? No, it is not. It's not part of that group at the very top. So it's a weak acid. So this will happen. This will form. It won't push back 100%. And we know that the top one is the same thing because NH3 is not going to push back all the way. So both are happening. So is the solution going to be acidic or basic? That's what we want to know. Okay? So what we do for the top reaction is we look at the Ka. What's the Ka of ammonium? Ammonium, because it's acting as an acid. Sorry, what is it? 5.6 times 10 to the minus 10. Okay. And then we look at what are we looking at here? We're looking at if this reaction happens. So I need to know the Kb of NO2. How do you find the Kb from Ka? Yeah. So you're going to use the Ka of its conjugate acid. So come on. So this has a Ka of 4.6 times 10 to the minus 4. Oh my. So the Kb of this reaction is going to be Kw over Ka. So we get a Kb value of 2.2 times 10 to the minus 11. Okay. So K equilibrium constants indicate relative strengths of the acids or base, right? Because it tells you the ratio of products over reactants. So which is stronger, the Ka or the Kb? The Ka is stronger. So the acid wins. Okay? So this has a higher Ka, so it pushes this reaction. Now both are happening at the same time, but this is the reaction that's going to dominate. So we're going to get more of this than we are of this. So is the solution going to be above 7 or below 7? It's going to be slightly below 7. Okay? So Ka is greater than Kb. Therefore, the acid, quote unquote, wins. And the pH would be less than 7. Not a ton. Those are pretty close. You'll see in the next one we get more of a discrepancy, but it'll be slightly less than 7. We don't actually calculate the pH because that is a very complicated thing. And we don't do that. Yes. Sorry? University, maybe? I don't know. I don't even remember doing it in university, calculating it. But I'm sure it's probably in a phys chem class. But I didn't do it. Or at least I blocked it from my memory. That might be more of a truth. Because phys chem, it's called physical chemistry, is chemistry, physics, and calculus all coming together. Doesn't that sound like fun, people? Apparently not. I don't even think they worry too much about it in undergrad. You would just measure it if you needed to, right? Because we are, even what we're doing when we calculate pH, we're ignoring some stuff and oversimplifying it. Now, if you want to go to like 17 sig figs, really accurate and precise answers, you have to account for the second. Hang on. All right, here we go. All right, an amphiprotic salt. What does amphiprotic mean? Can be a base or an acid. So, what are we going to do? Here it is right here. So we have potassium hydrogen sulfite or potassium bisulfite. Do we care about the potassium? No. So we can ignore that. We have this, HSO3 minus 1. We have water. And I'm purposely writing this in the middle of the table, but you don't have to. So what can it do? It's amphiprotic. It can act as an acid or a base. If it acts as an acid, it donates a proton, and you get that. Or it can act as a base, and it'll accept a proton. And you get that. Okay. And the reality is both will happen at the same time. We just need to figure out which one is the dominant reaction. Okay. So let's look at the acid reaction. There's the acid. All right. We want the Ka. What's the Ka for HSO3 minus 1? 1? Yeah. 1.0 times 10 to the minus 7. Now we need the Kb for the reverse. Okay. I'm going to rewrite this just so it looks like we normally write things. So okay, it's acting as a base there. So Kb for this is going to be Kw over the Ka of what acid? H2SO3, sulfurous acid, right? What is the... Thank you. So if you do that, you get a Kb of 6.7 times 10 to the minus 13. Okay. So are we acidic or basic? We are acidic, and we're going to be somewhat fairly, we're going to be quite, maybe even quite acidic, because look at the difference. Minus 7, minus 13. This is super weak. This reaction is not happening very much. This is the prominent, so we're going to have an excess of hydronium ions, right? So the pH will be way less than, maybe not way less, but less than 7, because Ka is bigger than Kb. Okay, that's it. That's all you have to do is write the two reactions. If it's amphiprotic, acting as an acid, acting as a base, find the Ka of the acid of the acidic reaction, find the Kb of the basic reaction. Whichever one is bigger is the one that wins. If it's a salt, you just look at each ion, determine if it acts as an acid or a base, figure out the Ka, Kb, compare them. You just say, is it going to be acid or base? Okay. Acid basis part 1 is now over. All right. You can answer the questions in the book. I'm going to print off a review package. I'll go get it, bring it back to class. I'll outline the test tomorrow because I haven't made it yet. I have an outline of it. And then the rest of this block is review, and tomorrow's class will be a review, but I'll outline the test tomorrow for the test on Thursday.